Okay, we will find the project duration using simulation. So, well, actually, you can find the project duration by the critical path method, but in that method, our assumption is that the durations which we have estimated, duration for the activities which we have estimated, are the deterministic durations. That means there is a great degree of certainty about these durations. However, in many practical situations, the duration of the activities are not certain. So there is an uncertainty about the duration of the activities. So we are considering that case now. So for this case, we are going to use the same example as we did before for the drawing of the project network. So this is the data we have for the activities, and for each activity we need to estimate 3 times: optimistic, most likely, and pessimistic times. And the meaning of these times has already been explained to you in the lecture. So for the network, we only need the information about the activities and the immediately preceding activities, and with that we can draw the network. So the network which we can draw looks like this. Okay, we don't need to do the forward pass or backward pass calculations, but that is the that we do in the critical path method. Here what we need to focus is on the different paths, okay, for different paths in this network diagram. Let me start thinking. So different paths. So for example, ADJ is one path, ADJ is one path, and so these paths are from the start to the end. Okay, ADJ is one path. Well, we are not including start and end over here. And there another path is BEJ. BEJ. Similarly, there are some more paths. So, okay, so I have now identified all the possible paths. So there are 8 paths, as you can see from here. So we will use these paths for our further analysis. What I mean is that, for example, for the critical path is the one which is the longest path. So we have the values for the duration for each of these activities. If we add all these activities, and then we can get the sum of the duration of each path. So the longest of that path will be the one that will be called as critical path, and that will be the duration of the project. So we can set up this information about these paths in Microsoft Excel. Okay, so and then we can find the duration of each path, and then we can the maximum of duration of each of these paths will be the duration of the network. So this process can be repeated thousands of times, and then we can find a distribution of these durations, and then we can make some conclusion that how much percentage will be the chance that the duration of the project will be this much. So that is the idea behind the simulation. Okay, so let's do it using Microsoft Excel, and then the Crystal Ball software for helping us do the simulation. So let me start Microsoft Excel. Okay, I have now started the Microsoft Excel, and how I can start over here is that I can list the data, okay, in Microsoft Excel. So for example, activity, and I have activities from A, B, C, D, E, F, G, H, J, H, I, and J. Yeah, A, B, C, D, E, F, G, H, I, J. Okay, and then I have their pessimistic time. Yeah, well, let's just say pessimistic time with P, most likely ML, and optimistic O, or maybe optimistic first, pessimistic later. Yeah, let me see. Yeah, optimistic is first, pessimistic later. Okay. And now I will list out all the data. I will list out this data over here in Microsoft Excel. Okay, so now I have listed the activity duration data: optimistic, most likely, and pessimistic. Now the next step is to list out the different paths. So I remember the first path was ADJ, ADJ. Yeah, these paths I listed here: ADJ, BEJ, BEJ, and similarly I will list out other paths. Okay, so now I have listed out all these 8 paths which I identified before over here from this network. Okay, my next step is to invoke Crystal Ball software. So this, if you have not started Crystal Ball software, then you can start it from the options menu, files, options, because I have actually by default I have disabled Crystal Ball, so you can add it from files, options, add in, and then com add in, go, and then over here I will invoke Crystal Ball over here. Okay, it will take some time. Okay, use Crystal Ball. Okay, so now I can use the Crystal Ball over here. So for the Crystal Ball I will need to add one more column over here. That will be the simulated duration. Okay, simulated duration. Okay, so what will be the simulated duration over here? That will be this based on the distribution of these activity times. Okay, here one thing I need to mention over here is that what type of we need to decide what type of distribution for the activity duration we need to select in Crystal Ball. So there are various types of distributions. So for defining those distributions, which in Crystal Ball is set as the assumption, so clicking on the Crystal Ball tab, then I can click the define assumption. Okay, under the define assumption we have different types of distributions. So for this it is recommended that for the duration estimates for the activities, a beta PERT distribution is recommended. We can also use the triangular distributions, but it has been found that beta PERT distribution gives us more flexibility and it is more closer to the reality. Okay, so I will select the beta PERT distribution and I will click OK over here. So for this beta PERT distribution for this activity A, I need to define the minimum likelihood likeliest and the maximum time. So minimum is located here, likeliest is located here, and maximum is located here. And then I will click OK. So here I will have this simulated duration for this activity. So okay, so well, it is shown over here as 0, but that's okay for the time being. Okay, so I have defined the distributions in the form of beta part distributions for these activities, except two activities B and H, because these for activities B and H, all the three times are same, so therefore there is no distribution of the times. These times are constant for every time, every simulation. So since these times will be constant, so this will be kept, these times will be kept as constant, so I can just put it like as constant time over here, 20 for each. So these times will not be simulated in the crystal ball simulations. Okay, so all the other assumptions I have already set. So for example, if I want to check about this, then I will select this cell and then I will click the define assumptions, and then I can see the values 2, 14 and 32 over here already set. Okay, now the next step is to calculate the duration for each path. So for the calculation of duration for each path, we need to input some Excel formula. For example, for ADJ, it will be the sum of the duration of A, D and J, and in this case these are the simulated durations. So I will put equal sign over here, A is here, plus D is here, plus J is here. Okay. Similarly for BEJ, I will select B plus E plus J here. Okay, so in a similar manner I have entered the formulas for all the paths. Okay, next step is the find the project duration. Okay, simulated project duration. This is the simulated project duration. So this project duration will be the maximum value of all these values, maximum of all these 8 values. Okay, so you will use the max function and then that will be the maximum value, and this project duration will become our forecast value in the crystal ball. Okay, define forecast, and then that is the name is the for project or forecast. So I will click OK. So this will be the forecast value. So I hope now we are ready to perform the crystal ball simulation. Okay, so for performing crystal ball simulation, I have selected like 10,000 simulations, and then I will click this start button on the crystal ball. So now the simulation has completed.